Given the function y equals x, y prime is 1. That is straightforward enough. But behind the scene, what this really means is that given the function y equals x, we differentiate both sides of the equation with respect to the variable of the function, in this case, with respect to x. The derivative of y with respect to x is not 1, but it is y prime. That's why we write y prime. And the derivative of x with respect to x is 1. And so this is dy dx equals 1. That is straightforward enough. Similarly, when we are given y equals x squared, we just simply write y prime equals 2x. But what this really means is that we differentiate both sides of the equation with respect to x. When we write d dx, this means we're taking the derivative with respect to the variable. And in this case, if y equals x squared, then the variable of the function is x. And so d dx of y is y prime, and the derivative of x squared with respect to x is 2x, and we would write dy dx equals 2x. And so from this discussion, we see that if we were to take the derivative of y with respect to x, it is not 1, but it is y prime. Another notation for y prime is dy dx. And so y prime is dy dx. And what this really means is the derivative of y with respect to x is y prime, or y prime is dy dx. And so now we have d dx of x is 1, d dx of y is not 1, but it is dy dx, or simply y prime. Similarly, if we want to differentiate x with respect to y, notice that the two are not the same variables, and so we would write this at either x prime, or better notation, dx dy. Dx dy means the derivative of x with respect to y. For practice, d dx of theta is not 1, but it is d theta over dx. It is better to use this notation than just to write theta prime. D dt of x is not 1, but dx dt. D dt of t is 1. You can think of d dt of t as dt over dt. And that dt dt is 1, although nobody write dt over dt. The derivative of t with respect to t is simply 1. The trick is, when we differentiate an expression, we have to pay attention to the variable. If the variable of the expression or the function is the same with respect to variable, then we would take the derivative like we would normally do. But if we differentiate with respect to a different variables, we have to be careful. The derivative of y squared minus x, we use the difference rule. We state that we need to take the derivative of the first term minus the derivative of the second term with respect to x. The derivative of y squared with respect to x, since they do not have the same variable, we would have to take the derivative like we would normally do, but we would have to multiply a dy dx or y prime. For the derivative with respect to x of x, it is simply 1. Another way to see that the derivative of y with respect to x is dy dx, or the derivative of y squared with respect to x is 2y dy dx, is to think of y as the function f of x. And so if we were to differentiate this function, we would write y prime equals f prime of x. But by definition, this means the derivative of y is y prime. Because y is f of x, the derivative of f of x is y prime. As we can see, this is not 1. Similarly, to differentiate y squared with respect to x, we can think of y as a function of x. That is, y equals f of x. And so the fact that we write y squared, it is actually f of x squared. And so we call this function capital F for example. And so the f prime, which is the derivative of the y squared with respect to x, is, using the chain rule, we would have to take the 2 and put it in the front, and then we would rewrite the function. Remember that we never evaluate the derivative inside the derivative, and so we would have to write f of x again, and we lower the exponent by 1, and then we would multiply the derivative, which is f prime of x. But this is 2, f of x is y, and f prime of x is y prime. And this shows that the derivative of y squared with respect to x is 2y times y prime, or 2y dy dx.